Okay, Jake, we're going to review for your test tomorrow. So I have in front of me the review sheet for matter chemistry core assessment. And looks like there's a couple diagrams and then essentially a strategy to try to figure out how to read the diagrams. And then it seems like some vocabulary terminology is really what the test is going to be about. So the first thing, which is number 1, it says label each part of the element box from the periodic table. So I have a feeling that you're going to have to label the parts. So what's going to happen is there's going to be a square in front of you. You're going to see that there's a spot that has a little number, a big letter, a word of an element, and then another number. And essentially they're going to want you to know what each one of these numbers are and what the symbols and stuff like that mean. So the first thing is this little number right here that happens to be 8. It's called the atomic number. So that's your atomic number, is the thing at the top. Then you have here your capital letter. That's the symbol for the element. So each element has its own distinct symbol. Then you have your element name. So this is an element, which is, a part of matter. And this one is called oxygen. And then you have the atomic mass. So that's the atomic mass of the element. And in this instance, it's 15.99. So I have a feeling she's going to give you something like that. And you're going to have to write atomic number, symbol, element name, atomic mass. Okay. So there's the atomic number at the top. Think of it like a sandwich. Atomic number here, atomic mass here. So the number, the mass, and then symbol and element name in the middle. Okay. Label each part of the atom below. So this is an atom. Okay, looks like a bunch of circles to me, but it's an atom. So you have here what are called electrons, neutrons, and protons. So the electrons have the negative signs. See them? Neutrons have no signs. See them? And the protons have the positive. So electrons are the minus signs, neutrons are the no signs, and the protons are the positives. The nucleus is the circle here, which house your neutrons and your protons. And then the energy level / cells are these bigger guys that go around the nucleus. Okay? So electron, neutron, proton, nucleus, energy level / shells. So now it says using the periodic table, name the element described below. So she may give you some information about what has 17 protons, 17 electrons, and 18 neutrons. So you're going to have to go and try and figure that out. So in this one, she's talking about chlorine, and it says explain why you chose that element. So it says this element has an atomic number of 17 and an atomic mass of 35. So I know it'll have 17 protons and electrons and 18 neutrons because 35 minus 17 equals 18. Okay, so apparently you have to do some math. So this element has an atomic number of 17 and an atomic mass of 35. So you're going to have to do some sort of math stuff to come up with the fact that it's got 18 neutrons. I'm hoping you know how to do that. So here's the atomic number here. So it would say 17. And then the mass is here. It says 35. So you know it has 17 protons and electrons because of the atomic number. And you would figure out how many neutrons it has by doing the math. Okay, that makes sense to me now. All right. Now it says I'm an element which has 10 protons, 10 electrons, and 10 neutrons. So you would go to the map, and essentially you're looking for something that has the 10 here, the atomic number. And it would want to have the 20 here because 20 minus 10 equals 10. So this element has an atomic number of 10 and an atomic mass of 20. So I know it will have 10 protons and electrons and 10 neutrons because 20 minus 10 equals 10. So the number of protons and electrons will be indicated here. And then you have to subtract that number from this number to find out how many neutrons it has. Cool. All right, number 4. Using the 3 beakers below, show the molecular movement in a solid, liquid, and gas. In beaker A, show the molecules in a solid. Look, they're all real close together. That's easy peasy. In beaker B, show the molecules in a liquid. They're a little bit more spaced out, and there's movement. And then in C is gas, little molecules, but they're spaced out. Okay. Now we're going to talk about physical properties versus chemical properties. So name one physical property of a piece of paper. So that's what it looks like, what you can feel, what you can see. So it's white, it's rectangular, it's flexible, it's smooth. Now it says name a chemical property. So it is flammable, or it has the ability to be burned. So that means it can go from paper to ash. So that's the chemical property. So number 7, it says Mrs. Voorhees spills a beaker filled with water on the cement sidewalk in front of Penwood. Which part of the water cycle would cause the water to disappear? So if it's going from a liquid on the sidewalk and the hot sun beats down on it and then it turns into a gas, that's called evaporation. Number 8, what is the basic unit of mass in the metric system? Grams. So when we talk about mass, we talk about grams. What is the basic unit of volume in the metric system? So we talk about volume, we're going to talk about liters. Volume has a lot to do with water, so you would say liters. Number 10, what is the basic unit of length in the metric system? Meters. So mass equals grams, mg. Volume equals liters, VL. Length equals meters, LM. All right, so it's grams, liters, meters. Now write the formula that would be used to calculate density. This is the D equals heart that you told me about. So density equals mass over volume. Number 13, label each as a compound, mixture, or element. Okay, so element is the basic unit of measure. It's tiny little guy, basic little guy. Compound is when you have two or more elements together. And a mixture is when you have a bunch of stuff that's mixed together. So a tossed salad is heterogeneous, but it's a mixture. It's a mixture. So mixtures can be heterogeneous or homogeneous. So if you look at the mixture and it all looks the same, like one thing, then it's the homogeneous. If it's mixed together and it looks like a bunch of different pieces, then it's heterogeneous. So a tossed salad has like carrots and vegetables and lettuce and stuff like that. It's heterogeneous. Hydrogen is an element. It's just, you can find it on the periodic table. Glucose is a compound. It's a number of different elements that combine together. Silver is an element. It's on the periodic table. Salt is a compound. It's a number of elements that are combined together. Pasta salad, which I love in the summer, is a mixture, and it's a heterogeneous mixture because there's different parts, different types of parts that get mixed together. Salt water is a mixture, and it's homogeneous because when you look at salt water, it's all one looking thing. Coins are compound. Oil and water is a mixture, heterogeneous mixture. Okay? Why is salt water a homogeneous mixture? Salt is a homogeneous mixture because when salt dissolves in water, it spreads evenly throughout the water, so you can no longer see the salt or the separate parts. So it looks like one thing. Remember what we talked about in reference to the term homo. Homo means one, means the same. All right, so number 15, the density of 3 liquids are 0.9 grams per centimeters cubed, 3.4 grams per centimeters cubed, and 1.9 grams per centimeters cubed. Mrs. McDaniel is combining all 3 of the liquids into the beaker below. After time has passed, which liquid will be on the middle, bottom, and top? Use the beaker below and the numbers above, write in which liquid will be on the bottom, middle, and top. So pretty much it looks like you just go from least to greatest. So the lowest is 0.9, that's the smallest, so that floats on the top. Then you have 1.9, that's in the middle, and then 3.4, that is the heaviest, the most dense, so it stays on the bottom. Okay, calculate the volume of a box that is 14 meters wide, 18 meters high, and 22 meters long. Show your work and circle your answer. So volume equals length times width times height. So you multiply your numbers, 22 by 14 by 18, and you come up with 5,544. And she's giving you a warning right here. Do not forget your unit. M equals cube, M cubed, M cubed, M cubed. Do not forget your units. M cubed, M cubed. Wiki, 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 wiki. M cubed. Don't forget your units. I'm assuming she's putting that there because students have forgot their units. Don't be one of those students. All right. Calculate the volume of the prism and show your work. Put the answer on the line provided. So here we have measurements 4 centimeters, 6 centimeters, and 15 centimeters. So volume equals length times width times height. So you just go 15 times 4 times 6. You don't even have to realize which one's width and height. You just know that you have to multiply all 3 of them. And you get volume equals 360 centimeters cubed. And what do? Don't forget your units. Centimeters cubed. Wiki, 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 wiki. Centimeters cubed. Don't forget your units. Okay? All right. That's it for the study guide. Seems like a lot. You got this. Finish strong, Jake Woodard. I love you. Peace.